Hey, hi everyone. Good morning, good evening, good afternoon from everywhere in the world. My name is Satish. So today's session is about unlocking language insights, which is all about building a Presto connector and which connects to large language models. Towards the very first, we'll first talk about a bit on Presto. I understand everyone knows what Presto is about, but we'll switch back to what large language models are. This is overall what is the introduction in terms of the agenda. So overview of large language models in Presto. We all know what Presto is in terms of definition and features. Yeah, it's mostly about reading about data, and your data could be in different data sources, could be in a MySQL data, but very recently you could understand that a lot of mm, crazes about large language models, and these could be hosted in one of the open source models using Olama. It could be in some proprietary data store like an OpenAI. So how do we leverage this data? Because when you can think about large language models, we can query them. Any user can go and ask them. But I think when you talk about Presto as an engine, I think one of its key capabilities is connection towards a lot of federated data sources. I think that's what makes Presto and large language models a very unique combination. Uh, and to express Presto in a very simple, model, you can query Presto using SQL as its primary interface. And Presto basically uses a lot of connectors, plugins, data types, or functions to connect to different data sources. It doesn't mind, what kind of data you're storing in these data sources. Eventually, it all matters about how you are mapping your data source data to what Presto understands in terms of the SPI interface. Now, this is a very, basic model of what a large language model is and how it performs. If you see, you can give an input, a query to a large language model. In this case, the blue box is kind of an OpenAI model. And sure, it can give you an output. That's a very simple model of, how a large language model, you put an input, a query, and it answers based on its understanding or previous knowledge of some context. But eventually, there's also other parts that organizations have their own data. And whenever you query, you want that contextual data. So that is where the RAG pattern comes, retrieval augmented generative context. And to add to it, in terms of large language models, you also have prompt templates, in terms of not only give it a particular input, but also improve the, in terms of expectation out of the model. It really helps them, to fetch you a perfect answer, which is more suitable towards your industry or your particular context at hand. One of the issues which is more prevalent towards large language models is hallucination, which sometimes give you answers where do not have the facts. So that is where sometimes the prompt templates help there. But we'll check more towards as we go in the session deeper. Now, we saw two parts here. The one is the Presto model, and the second is the large language model. But if we combine both of them, where you see the query hits Presto, and one of the connectors can connect to a large language model. So this is where today's session is about how this and how we can build one such, and eventually how do we improve this in the future. There's a very simple picture which I took from, it's a very good book. You can learn about it from Learning and Operating Presto. It's also available courtesy of IBM and compliments. It's a very simple model which I think tells about, how can we build a connector using different connector IDs, metadata, client, and all these are built as Java classes, which eventually interact with your end data source and map the data to the Presto engine. Oh, why do we care about this integration? The very first is I think it gives us a lot of features. One is enhanced natural language processing, giving which is a very important characteristic that business and many developers can use SQL just to generate insight to the data. But not only this data, but let's say you have other data which is present in other data sources, let's say, which can be fetched from a large language model or OpenAI. Uh, your plethora of different can be combined with your data sets, but also let's say you want to generate kind of, let's say you have a customer review in one of your databases, but you want to generate what is the kind of the support or the feedback, was it a positive or negative, generate which interacts and sends that particular to a large language model and it on it and integration. Now, some of the key face so include as part of it. The next one is initiate the OpenAI client builder. This is what helps you to connect to OpenAI. The very first step we have taken here is to first using the OpenAI model. This can be improved and further augmented to build upon more open source APIs, maybe Olama and OpenAI and others too, which you can connect. And this can be based upon how do you enhance these features, based upon whether tomorrow you want to connect to Bedrock or Amazon Bedrock, etc. So this is one of the starting points where it first connects to OpenAI and sends that particular data and gets a feedback on it for a particular answer. And some of the key design principles is how do we make it efficient? So that because we're connected to an external system, then large language models usually are very slow. Eventually, because they are probabilistic and they have to generate these probabilistic next token. So that is why we have to take care of how do we make it efficient, and eventually there's a cost factor there. So there is always a balance between how efficient a system like Presto can be and how do you make it scalable enough. There are two parts to it. The very first is in order to use this uh, connector, we just have to provide the connector name, which is the OpenAI LLM, and a metadata URL. This for I've just shared a sample URL. It can be at any URL where you're hosting this JSON file, and the JSON is in a very similar structure here, where you can host different here. One particular parameter is OpenAI. Maybe tomorrow you can create another parameter associated with it, like Olama or Bedrock. And basic parameters to start with. The very first is the name with the LLM, and the column is like a question and answer. The question is what you search for, and the answer is what you're getting a response from the OpenAI interface. And the third one is the key, which is your the secure parameters. So this is the key code which is used to interface with OpenAI, and we are using GPT-4o model. Here, basically, if you see, we are fetching a particular response, and the very first, if you see, we are just saying you are helpful assistant and help answer following question. The question is the parameter which we receive from the input from the SQL query, and then we send it to the OpenAI system. Once we receive a response from OpenAI, we then send it as a response back to the SQL output. That is a very simple interface which we are targeting as part of the initial MVP model. Now, before I proceed, I'll just show a very simple demo of it, which I have handy here. So if you see, there's a very simple query, and I'm just, it's a catalog example, and the schema is OpenAI, and the table name is LLM. Where now I'm asking it a question here that tell me something about Presto. There's a question I'm asking. Now, when I hit this interface, hit OpenAI, this is the very first, part of it, where it tries to, hit the endpoint here. Just a minute. So it'll take some time because it's again fetching it from OpenAI. But if you see it fetch this very important information and it kind of supplementing here query which I wanted to share of the use of this particular connector. Now, moving on, some of the pretty important challenges with because there's a pretty initial MVP model here, which we are talking about. But when we think about, improving it, some of the important challenges which we'll be facing is how do we improve the performance optimization? Because we are dealing with a lot of text, and eventually prompt engineering is a very important factor as to because every organization, every industry, every context has their own individual importance, and it all depends upon your application and what are you trying to derive. And the second part is, there's all real-time processing in terms of how you're fetching all this data from OpenAI and all these different large language models. So it's very important that uh, we take care of the milliseconds of optimizations in terms of how to you can fetch the data on a streaming basis, or you want to first fetch the data and then show it. So there's always a level of user experience which we have to deal with here. And with that, we can think about some caching and optimized query execution, but that is more in tune with how do we build this in the future. Some of the very simple real world use cases, and it can depend on a lot of factors, and it all depends of how what kind of data you're storing. Let's say for a healthcare industry, it all depends on analyzing medical records. So you have a simple SQL query and you want to transform these records and get some analysis on top of them and get those from a picture and multi-modal kind of not only deal with text but other kind of data. So how do you use this data to generate more insights out of it? And that is could simply help you by gathering and connecting this data and giving you these very instant feedback, and all in the same Presto interface which we all know about. And similarly, you can correlate it with other industries similar to finance and customer feedback analysis in the retail sector, etc. So in the very start, the initial task, what it does is it connects a particular query to the OpenAI system and gives you an answer. And if you think about the very simple system, it may not be very helpful, but it gives you some insight. The second, the some of the future work associated with this connector is create these functions which enable you to uh, gather insights out of your existing data by fetching it from one source and executing these functions on those particular data or columns. The second is when you think about generating these data from large language models, eventually you have different validation parameters because you have to check hallucination, and eventually all these validation frameworks are already existing. We just have to build them around it and think about how do we bring them some of them into the Java environment because of the plugin environment built into Java. The fourth is build more context generation by doing the joins to more federated resources by having them connected to other data sources. So these are some of the future works which we are planning. Uh, and to conclude about this session, the key takeaways is there's a lot of transformative potential of large language models and data analytics, and particularly in terms of generating real-time insights. And it's very helpful when you see that from a single unified interface. There's a lot of future prospects for innovation around this. I think open source is one of the key initiatives where we can collaborate, and I think some input from the community and contribution would really help this connector go a long way. So if anyone is interested in how to create Presto connectors and contribute to this, I think they're more than welcome to do that. If we have any questions, I'm open to that. We have, I think, 3 to 4 minutes.